Good morning, everyone. Today we'll be dealing with topic posture. Contents will be definition and introduction, types, active and inactive posture, postural reflexes, and last one, postural mechanism. Definition and introduction. When we define posture, it is nothing but it is an attitude assumed by the body, upper limb, lower limb, either to maintain a single position that is static or in order or sets of various different posture in order to have a smooth rhythmic movement. It is just the coordination of the muscle group, that is your antagonist and agonistic muscle, working together to maintain stability and equilibrium during either static posture or even dynamic posture. Coming to types of posture, there are two main types of posture, that is active and inactive. Active, where the integrated muscles need to work to maintain the active posture, whereas in an inactive, there is minimal muscle work. There are two types of active posture, that is static and dynamic. In static posture, a person is just maintaining constant position for a certain longer duration, whereas in dynamic posture, there is frequent change in the position or a set of different postures attained during the moment. In inactive, usually these positions are used during rest or sleeping phase. Coming to postural reflexes. Postural and locomotive reflexes of the spinal cord are two main reflexes. One is positive supporting reflex and one more is righting reflex. Coming to positive supporting reflex. When a pressure is given to at the football or foot pad or the ball of the great toe, there is extension against the pressure seen. First, there is flexion and then there is gradual extension seen. So, when there is foot is in extended position, give a pressure on the ball of the ball of great toe or the foot pad, you will definitely see first flexion and then comes the extension part. That is extension against the pressure being exerted. That is nothing but positive supporting reflex. Coming to the next type, that is your spinal cord righting reflex. Here, spinal cord righting is nothing but alignment of a body part along with the head. So there's something called as equilibrium axis, which starts from the cortical control, which is developed through the age as the age progresses, which is known to maintain stability and balance in both static and dynamic posture. That is alignment of the head with the trunk. That is nothing but spinal cord righting reflex. Coming to the roles of nuclei, that is reticular and vestibular nuclei. Sorry for the spelling mistake. These reticular and vestibular nuclei are very important in maintaining posture, in maintaining a erect posture. How? Reticular nuclei, there are two types of reticular nuclei, so as vestibular nuclei has two types. These nuclei get the signal from the brain, send it to the extensor muscles of the body, which maintain the position of the body straight and erect. One of the nuclei among reticular nuclei is facilitatory for the extensor muscle, and the other one is inhibitory for the extensor group of muscles, whereas vestibular nuclei both are inhibitory to the extensor group of muscles. Let's look at the nucleus and its function. Coming to reticular nuclei. As I already told, it has two types of nuclei. First one, pontine reticular nuclei, which is facilitatory, medullary reticular nuclei, which is inhibitory. Pontine reticular nuclei it's located in starts from pons, extends up to mesencephalon, whereas medullary reticular nuclei extends in medulla. Coming to the reflexes, how reticular nuclei acts as a reflex system for extensor muscle. As I already told, the brain stimulus is passed through the spinal cord where the reticular nuclei are present and then taken to the extensor muscle. As I already mentioned that there are two types of reticular nuclei, that is your pontine and your medullary. So as the diagram consists, the green one suggests the facilitatory, whereas the red one suggests the inhibitory. The black one suggests the central spinal canal. So the green one, as I already told, it is facilitatory, which is nothing but pontine reticular nuclei. Red one is inhibitory, nothing but medullary reticular nuclei. So the stimulus is taken from the brain, passed through the pontine reticular nuclei further to the extensor muscle, which facilitates the contraction of extensor group. The stimulus is taken from the brain, passed to the uh, medullary reticular nuclei to the extensor muscle, which acts as inhibition, which is nothing but inhibitory supply to the extensor muscle. It inhibits the contraction of the extensor group of muscles. These are the two types of reticular nuclei, hence two types of reticular nuclei reflexes, while maintaining the erect posture. Coming to the vestibular nuclei. So, as I already told, vestibular nuclei, also there are two types, that is your medial vestibular nuclei and lateral vestibular nuclei, where your reticular nuclei, sorry, medial and lateral vestibulospinal nuclei, where your reticular nuclei had one of them facilitatory action on extensor muscle and one of them an inhibitor action on the extensor muscle. Both medial and lateral vestibulospinal nuclei have inhibitory function or inhibitory action on extensor muscle. Let's look at where the nucleus are present. This is nothing but your brain, spinal cord, and extensor muscles, where your both the red, that is your one is medial vestibulospinal nuclei, one is your lateral vestibulospinal nuclei, and the black one in the center is your central spinal canal. As already mentioned, medial and lateral vestibulospinal nuclei, and then your central spinal canal. So, the stimulus is taken from the brain, passed through the medial vestibulospinal nuclei, taken to the stimulus is further taken to the extensor muscle, which has inhibitory action on the extensor group of muscle. So, as the stimulus taken from the brain passed through the lateral vestibulospinal nuclei to the extensor muscle, again having inhibitory action on the extensor group of muscle. So hence, medial lateral vestibulospinal nuclei along with the medullary reticular nuclei have inhibitory action on extensor muscle, whereas pontine reticular nuclei only has facilitatory action on extensor muscle. Hence, these are the reticular and vestibulospinal nuclei reflexes in maintaining the posture. Okay, coming to the next part, that is your vestibular postural reflex. Any sudden change in orientation of a human being in the space elicits reflexes that helps to maintain equilibrium and posture. Now, what are the reflexes? First one, push right. That is, right leg is extended. Second one, forward push. Upper limb extends and the extensor muscle tightens and the muscles in back and neck stiffen to prevent the falling. These are nothing but vestibular postural reflexes. Coming to the next one, postural reflex, the main part. A reflex, by definition, is an efferent response to an afferent stimulus. Let the stimulus be anything and let the reflex be anything. For example, the stimulus is hot pan. You touching a hot pan, withdrawal of your hand is nothing but a reflex. So that is nothing but withdrawal reflex. When you touch a hot pan, which is a stimulus efferent, you withdraw through using withdrawal reflex through efferent response. The efferent response is the motor one. Even in postural reflex, efferent response is the motor one. The anti-gravity muscles being the principal effector organ to maintain the posture. Efferent stimuli, that is your towards the brain stimuli, arise from variety of sources. We will be discussing these further. Let's just memorize them. Muscles, the eyes, ears, and the joint structure. Each one has some sensors to pick up the signal from the muscle, which are passed through various PNS to the brain and spinal cord. Coming to the receptor organs, that is the first one, muscles. Muscles have two receptor organs. One is GTO and one is muscle spindle. GTO responds to faster contraction or faster stretch stimulus, whereas spindle responds to slower contraction of the muscle or slower stretch response. This is nothing but the tension within the muscle changes when either you stretch the muscle or contract it. Hence, increased tension in the muscle leads to reflex contraction of the muscle. Once the muscle, when you are falling, there is sudden increase in the tension of the muscle. This leads to reflex contraction of the erector spinae or your extensor group of muscle. This is nothing but stretch reflex. This is just a brief of stretch reflex. I'll be dealing with stretch reflex in detail. Let's look how the muscles respond to being a receptor organ. Consider this is a muscle. The red structure present at the tendon are called as GTO, that is Golgi tendon organ. As the name suggests, they are present on the tendon. So I already told GTOs activate when the muscle is either fastly contracting or fastly stretching out. So stretch the muscle fast, GTOs are contracting. So this is nothing but GTO. We also know that there is something called as muscle spindle, which are present on the muscle fiber, which respond to slower contraction of the muscle or slower stretch. So this is responded by the muscle spindle, which are present on the muscle fiber. So this is the receptor organ of a muscle part. Now coming to the second organ, that is your eyes. We already know eyes are present on the head and face part, which is present or standing on the trunk part. So when you tilt your neck at the side, your eyes are not looking straight. They are also tilting along with the head. So your orientation of eyes with respect to the object when you are looking straight is different, and when you're tilting your neck is different. Hence, this visual stimulus, the orientation of the object in front of you is sent to the brain, which tells, hence that time the brain tells the head muscle or the neck muscle that the neck and head is not aligned with respect to the body. Hence, align the neck and head right back to its normal. That is nothing but your righting reflex. So please make sure when you're looking at the object in a straight way, the brain understands that your head and neck is aligned right on the top of the body. But when you're tilting your neck to the side way, your eyes through the eyes, the stimulus of the object, the orientation of the object is sent to the brain, where the brain recognizes that head and neck is not aligned in the straight line with the body. Hence, it tells the head and neck to align itself back to the body. That is nothing but your righting reflex. Coming to the third organ, ears. We already saw eyes are your receptor organ. So, in a similar way, so does your ear function. When you move or your neck in one side, that is your lateral flexion, the fluid in the internal ear, that is your in the semicircular canal which are present in the internal ear, is disturbed. The flow of the fluid within the semicircular canal is disturbed. This signal is sent to the brain. That time the brain realizes that my head and neck is not aligned with my trunk, is not aligned in a straight line with my trunk. Hence, it sends the signal to the musculature of the head and neck to align it back to the center, that is right on the top of your trunk. That reflex is known as vestibular reflex. Coming to the fourth point, that is your joint structure. Imagine this is your tibia. So, joint structure, the receptors present within the joint structure are your proprioceptors. So, make down, draw tibia, mark some proprioceptors on the surface of the tibia. So, on the top of the tibia, which bone is present? That is nothing but your femur. So, when there is the load within the joint surface, that is when you are on the loading position of the joint, the proprioceptor sense this mechanical load and pass on the signal to the brain. These proprioceptors tell the brain that what is the position of the joint during the loading time. Whether my knee joint is in flexion position during loading or my knee joint is in extension position during loading. That is nothing but joint position sensation, and aligns the joint when the brain thinks, when the brain gets to know that my knee is in flexion when it has to be in extension, brain sends back the signal telling the knee to extend, telling the knee musculature to extend and align accordingly whatever is needed. So these were the postural reflexes and postural mechanism. Let's meet you all in the next video. Thank you, one and all. See